Welcome all. It's a great day for pre-calc. Today we're going to take a look at circles and ellipses. And away we go. Let's begin with the standard form for a circle that you learned back in geometry. Again, recognize the important features of the circle. The center, once again, HK, and the radius will be located here, however it will be squared. Alright, and then in green you'll see all the possible formulas that you might need when doing work with the circle. Okay, so we're just going to do two things today. We're going to sketch one, and then we're going to take a sketch and write an equation for it. So let's begin with this one. Alright, and our goal is to sketch it. Alright, we're going to look for the center, which is located at HK once again. Alright, notice if there's no parentheses here, then we're looking at 0 for H in this case. Over here, we see the -3, which means K is positive. Now you'll plot that and be a good labeler. Alright, and finally, alright, we know that the radius squared is 64. So square root of that will give us 8 for the radius. Alright, now we need to go 8 in every direction. However, for your purposes, we just want you to go 8 and up and down and right and left. Alright, and remember, be a good labeler. We're going to go 8 this way, 8 down, and 8 sideways. Now do your best. Connect these with a smooth curve, and we'll have to adjust that. Make sure you hit your dots, and you should get something resembling a circle, as long as there are no jagged edges. Don't draw a diamond. Alright, we'll call that a circle, even if it looks a little bit like a mashed potato there, or baked potato I should say. Alright, and you won't believe this, the most missed is going to be the diameter. Alright, we know that the diameter is merely the radius twice, and the answer this time is 16. However, we see 64 quite a bit there. People going too fast because they know it's not so difficult. Alright, so that's how we sketch a circle. Next up, now you could be given a picture or some information. This time they just gave us the center and the radius, and they would like for us to write an equation in standard form. Alright, so we're going to take H and K, plug them in. Alright, if it's -1, then this will turn into plus +1, and K is 7, so that will be -7. If there's a trick here, it's right with the radius squared. When we square the square root, poof, the radical disappears and the 8 remains. Here is the proper equation for that given information in this circle. Alright, with that, we will move to ellipses. Okay. And recall the ellipse very much like a circle. However, we won't be going the same distance in all directions, which will make it an ellipse. Let's start with these two formulas for the ellipse. Notice it equals 1, not r squared. And notice that we've got a squared and b squared switching places. Those are the only differences in these two formulas. All right, and we'll call a the big guy every time, b the little guy. All right, when the big guy is under x, notice your ellipse will be horizontally stretched, and when the big guy is under the y, it'll be stretched vertically. Okay, so there you have those. Now, what are the important things we need to know about an ellipse? Here's the picture. Like the circle, it has a center. All right, but instead of going radius in all 4 directions, all right, we will take baby A and we'll go that distance in both directions, depending upon which letter it's under. In this case, it's under X, so we went A units right and left. All right, and B was under Y, so that was the distance to what are called the co-vertices. Okay, over here, these were the vertices. And finally, baby C, which is not pictured here yet, all right, that's once again going to represent our focal length. Okay, notice also the major axis contains all the good stuff, the vertices, the focal points, and the center, whereas the minor axis is the shorter one, only will contain the co-vertices and the center. Okay. Oh, and I do have 3 what I term useful add-ons to your notes here. Okay, first you're going to notice a little formula. It looks like the Pythagorean theorem, but it's going to have a minus there. All right, and what that will be used for is to find baby C. All right, the eccentricity refers to the roundness of the ellipse, and that's going to be baby C over baby A. Don't you call that a D. Don't act out. Okay, and then finally, all right, may or may not use this, but if you put a point anywhere on the circle, all right, those measurements, when added together, will give you twice A, which is the length of the major axis. Okay, never know when that'll come in handy. All right, so like the circle, okay, we are going to struggle bus here. Oh my goodness. All right, we're going to sketch one. And we'll start with this equation right here. Notice it doesn't equal 1. So that's got to be our first step. We're going to divide everybody by 225. All right, and my cashiers know how many quarters are in $2.25. Hope that's still 9. That'll give you 9, and this will give you 25, and of course this will give us the one that we desire. All right, it is now in our proper form, and we can sketch it. Okay, so with that said, here we go. Starting with the center. All right. We have 1 for H, and we see +3, so we write -3 for K. So put that on your picture, and be a good labeler. That is the center. Now notice the bigger number is under Y this time. So our major axis is going to go vertical, and we'll include our vertices and our focal points. All right, so how far are we going to go up and down? If that's a squared, then baby A says to go up 5. So we're going to go up and down 5. And place dots. Okay. If this is B squared, then B is 3. So we're going to go sideways 3. And again, smooth curve will give us our ellipse. Okay. Now, in being a good labeler, said these were the vertices, 1, 2, and 1, -8. And we said these were going to now be called co-vertices. All right. 4, -3, -2, -3. All right. And our 2 axes, we said the major is going to be that one, and minor going horizontally. Let's name those. The major goes through the x-axis at 1. And the minor goes through the y-axis at -3. And finally, our eccentricity, baby C over baby A. All right, we're going to need to roll out that useful formula I told you, and we're going to do big minus little. So we're going to do 25 minus 9. Which means baby C is 4. We're going to go 4 up and 4 down to find our focal points. And we can finish the problem now with the eccentricity baby C, 4 over baby A, 5. And that's that. All right. So we've sketched one. Now we're going to be given a picture this time. And we're going to be asked to write an equation. So off we go. And never a bad idea, what did I say, to write down that point so that you can see H and K and put them in the proper places. H is 5. K is -3, which makes that plus. Okay? This distance getting us to the vertex on the major axis is baby A. How long is that? 4. So we're going to square it up and place it under the X since it was going sideways. This unit here is baby B, and it went up 1. Square that up and place it under y. This is the equation for that ellipse in standard form. And we'll close our day with the toughest one, naturally. Ooh, that's a monster. Now, you'll notice it is not in our proper form. We couldn't tell where the center or anything will be until we complete the square. So away we go. Okay, first thing I want you to do is isolate the constant. Move that over. Okay, then I also want you to gather the x's and gather the y's. Alright, when we completed the square in parabolas, we had to put the boxes at this step, but we're not ready yet. Okay, we got some troublemakers. This 4 needs to be a 1, so we're going to move them out. And how do we do that? We divide 4 away from both of those, leaving x squared plus 6x. Now, a purple box on both sides. Okay, and do the same thing with 25. And we'll put an orange box on both sides. It is now ready for us to complete the square. We're going to take half of b, which is 3, and square it. 9er. But it's not really 9, it's really 36. So that's what will go in this box. For the orange, half of 2 is 1, 1 squared is 1, but wait, it's not really 1, it's really 25. Okay, now you have completed the squares. We got to figure out what they are. If you factored this, you get x plus 3 times x plus 3. That is the perfect square you created. How about over here? Perfect square for this guy is y minus 1 times y minus 1. And finally, these guys add up to 100. But we need it to equal 1. So we're going to divide everybody by 100. And look at what happened. We have x plus 3 over 25. Y minus 1 over 4. And we've got the 1 we desired. It is now in the proper form where we could pull the center and any other important pieces out. This masterpiece is done. And so are the notes. Hope you got something out of it, and have a wonderful day.